A glimpse into humanity's fragile future. In the vast timeline of Earth's history, human existence is but a blip, a mere moment in the sprawling chronology of the planet. Yet, in that short span, humanity has made unprecedented progress. We've developed languages, built civilizations, and advanced technology to a point where the future seems boundless. But beneath this achievement lies a fragile foundation dependent on delicate ecosystems, stable climates, and finite resources. This chapter sets the stage for understanding the safe zones, geographical areas on Earth that have historically shielded us from the worst environmental catastrophes. These regions, often defined by their temperate climates, rich biodiversity, and minimal natural disasters, have been crucial for sustaining human life. From the Fertile Crescent of Mesopotamia, where human agriculture began, to the vast plains of North America, where abundant resources fueled industrial revolutions, these regions have been vital in fostering human civilization. These zones offer moderate temperatures, ample rainfall, and fertile soil, conditions necessary for agriculture and human habitation. But what happens when these once safe zones start to collapse? As the 21st century unfolds, we are witnessing a silent but accelerating collapse of these regions. Environmental degradation, climate change, overpopulation, and unsustainable practices are destabilizing the very zones that have sheltered us for millennia. The implications are staggering, with potential cascading effects that could reshape the future of humanity. In this chapter, we'll begin by exploring what defines a safe zone and why these regions have historically been so important. We'll trace the development of human civilization within these regions and introduce the concept of the final countdown, the idea that Earth's most stable regions are approaching a tipping point from which recovery may not be possible. Human civilization has thrived in safe zones for thousands of years. Ancient Egypt, for example, developed along the fertile banks of the Nile River, a natural safe zone that provided water, food, and a relatively stable climate. Similarly, the Indus Valley civilization flourished in the area now known as Pakistan and northwest India, benefiting from monsoon rains and fertile plains. Greece, Rome, and other Mediterranean civilizations also arose in temperate regions, where moderate climates supported agriculture and trade. These safe zones offered not only physical security, but also opportunities for cultural and technological advancement. With stable food supplies, early humans could focus on building cities, developing governance systems, and creating art and science. But while these regions offered protection, they were not immune to environmental changes. Droughts, floods, and other natural disasters occasionally disrupted life in these early civilizations, serving as a reminder of humanity's vulnerability to nature. Fast forward to the Industrial Revolution, and the concept of a safe zone expanded to include regions with abundant natural resources, coal, oil, and metals that fueled human progress. North America and Europe became new hubs of human activity, where industry and innovation thrived. These regions were considered safe due to their technological advancements, democratic governance, and stable economies. But as human activities accelerated, so did the rate of environmental degradation. Industrial pollution, deforestation, and the overuse of resources began to destabilize ecosystems, threatening the long-term viability of these safe zones. The modern era, with its unprecedented technological and scientific advancements, has only exacerbated this issue. While the concept of a final countdown may seem dramatic, the signs of environmental collapse are becoming increasingly difficult to ignore. The Arctic, once considered one of the planet's most resilient regions, is warming at a rate that far exceeds global averages. This rapid warming is causing polar ice caps to melt, raising sea levels and threatening coastal cities around the world. Meanwhile, tropical rainforests like the Amazon, often referred to as the lungs of the earth, are being destroyed at an alarming rate due to deforestation, mining, and agricultural expansion. Yet, the collapse of these natural systems is not a sudden event. It is happening silently and incrementally, which makes it all the more dangerous. Unlike sudden natural disasters such as earthquakes or hurricanes, the slow degradation of Earth's safe zones occurs over decades or even centuries, making it difficult for humans to recognize and react to the changes in time. By the time the effects become undeniable, it may be too late to reverse them. One of the key drivers of this collapse is climate change. The Intergovernmental Panel on Climate Change, IPCC, has warned that global temperatures are expected to rise by several degrees in the coming decades if greenhouse gas emissions are not drastically reduced. This warming will lead to more frequent and intense heat waves, droughts, and storms, conditions that will erode the stability of many safe zones. At the same time, human activities such as deforestation, overfishing, and pollution are degrading ecosystems, reducing biodiversity, and diminishing the natural services, like clean air and water, that these safe zones provide. With more than half of the world's population living in urban areas, the pressure on remaining safe zones is greater than ever before. It's important to recognize that humanity is not a passive observer in this process. Human activity has been the primary driver of environmental change for centuries, and in recent decades, the pace of this change has accelerated dramatically. Industrial agriculture, driven by the need to feed a growing global population, has led to deforestation, soil depletion, and water scarcity. In coastal regions, overfishing and pollution are decimating marine ecosystems, while urban expansion is reducing the amount of land available for agriculture and biodiversity. Fossil fuel use is another major contributor to the collapse of Earth's safe zones. The burning of coal, oil, and natural gas releases carbon dioxide and other greenhouse gases into the atmosphere, trapping heat and causing global temperatures to rise. This warming, in turn, leads to the melting of polar ice caps, the acidification of oceans, and more extreme weather events. At the same time, the consumption of natural resources is outpacing the planet's ability to replenish them. According to the Global Footprint Network, humanity currently uses the equivalent of 1.7 Earths to sustain its activities. This means we are consuming resources faster than the planet can regenerate them, leading to deforestation, soil degradation, and the depletion of freshwater supplies. Let's conduct a thought experiment. Imagine a future where Earth's safe zones, the temperate regions, the rainforests, the coastal zones, have all collapsed. What would this world look like? Without these safe zones, large portions of the planet would become uninhabitable. Rising temperatures would make tropical regions unbearably hot, while droughts would devastate agriculture in once fertile areas. Coastal cities, home to billions of people, would be inundated by rising sea levels, forcing mass migrations inland. The collapse of ecosystems would also lead to a dramatic loss of biodiversity. As forests disappear and oceans become uninhabitable, many species of plants and animals would go extinct. This loss of biodiversity would have cascading effects on human societies, as the natural systems we rely on for food, water, and clean air would cease to function. In this thought experiment, humanity would be forced to retreat into smaller and smaller habitable zones, with conflicts over remaining resources likely to increase. Governments and societies would face immense challenges in maintaining order and ensuring the survival of their populations. While this scenario may seem extreme, it is not entirely out of the realm of possibility. If current trends continue, the collapse of Earth's safe zones could become a reality within the next century. But there is still time to act. By recognizing the warning signs and taking immediate action to reduce our environmental impact, we can help slow or even reverse the collapse of these vital regions. As we conclude this introductory chapter, we've laid the foundation for understanding the importance of Earth's safe zones and the dire consequences of their collapse. The silent unraveling of these regions is a slow process, but it is gaining momentum, driven by human activity, climate change, and the overconsumption of natural resources. In the chapters that follow, we'll delve deeper into the specific regions under threat, explore the science behind the environmental changes taking place, and discuss what can be done to prevent the collapse of Earth's last safe zones. Humanity is on a final countdown, and the clock is ticking. The choices we make in the coming years will determine whether we can preserve these vital regions or whether we will face a future where the Earth's safe zones have vanished, leaving us vulnerable to the harsh realities of a degraded planet. The crumbling foundations of Earth's safe zones. Throughout much of human history, climate stability has been a cornerstone of civilization's success. Moderate temperatures, predictable seasons, and adequate rainfall have allowed for the rise of agriculture, trade, and urban development. But in the 21st century, the stability of the Earth's climate is being fundamentally altered at an alarming rate. Global temperatures have been steadily rising, with the last decade recorded as the hottest in history. As climate stability begins to unravel, the consequences for Earth's safe zones are profound. The science behind climate change is well established. The primary driver of this shift is the increased concentration of greenhouse gases in the atmosphere, mainly carbon dioxide, methane, and nitrous oxide. These gases trap heat from the sun, causing the Earth's average temperature to rise. This phenomenon, known as the greenhouse effect, is a natural process that has kept the planet warm enough to support life. However, human activities, especially the burning of fossil fuels, have intensified this effect, pushing global temperatures higher and destabilizing previously reliable climate patterns. One of the most concerning effects of climate instability is the increase in extreme weather events. From heat waves and droughts to intense storms and floods, the frequency and severity of these events are rising. Regions that were once considered safe with predictable weather patterns are now facing unprecedented challenges. For example, Europe, known for its mild climate, experienced record-breaking heat waves in recent years, causing widespread wildfires and heat-related deaths. Similarly, in the United States, hurricanes are becoming more powerful, fueled by warmer ocean waters, while wildfires ravage the western states with greater intensity each year. These changes are not just theoretical, they are happening now, and they are putting immense pressure on Earth's safe zones. The implications for agriculture, infrastructure, and human health are significant. Crops that once thrived in certain regions may no longer be viable due to shifting rainfall patterns and rising temperatures. Coastal cities, home to millions of people, face the growing threat of flooding from sea level rise and storm surges. In the coming years, climate instability will likely lead to a redistribution of human populations as certain areas become uninhabitable, forcing migrations and sparking potential conflicts over resources. The polar regions of the Earth, particularly the Arctic, are experiencing some of the most dramatic effects of climate change. The Arctic is warming at more than twice the rate of the global average, a phenomenon known as Arctic amplification. This rapid warming is causing sea ice to melt at an unprecedented rate, with the Arctic ice cap shrinking significantly in both thickness and extent over the past few decades. This melting has far-reaching consequences for the global climate and for safe zones across the planet. One of the most immediate effects of polar ice melt is the rise in sea levels. As glaciers and ice sheets in Greenland and Antarctica melt, they contribute to rising ocean levels, which threatens coastal regions worldwide. Coastal safe zones from the low-lying islands of the Pacific to the densely populated cities of Asia and the United States are particularly vulnerable. According to the United Nations, sea levels could rise by over a meter by the end of this century if current trends continue, which would displace millions of people and devastate economies reliant on coastal infrastructure. But the effects of polar ice melt are not limited to rising sea levels. The loss of sea ice also disrupts global weather patterns. The Arctic acts as a cooling system for the planet, helping to regulate temperatures in the northern hemisphere. As the Arctic warms and loses ice, this cooling effect diminishes, leading to more extreme weather in regions far from the poles. For example, the weakening of the polar vortex, a large area of low pressure and cold air surrounding the poles, has been linked to colder, more severe winters in parts of North America and Europe. The melting of polar ice also has the potential to trigger feedback loops that could accelerate global warming. As ice melts, it exposes darker ocean waters, which absorb more sunlight than reflective ice, further warming the region and melting more ice. This process, known as the ice albedo feedback, is a dangerous positive feedback loop that could lead to even faster warming in the Arctic and beyond. The collapse of polar ice systems represents a critical tipping point that could push Earth's climate system into a state of irreversible change, with catastrophic consequences for safe zones around the world. While much attention has been focused on rising sea levels and extreme weather, another insidious consequence of climate change is occurring beneath the ocean's surface: ocean acidification. As the atmosphere absorbs more carbon dioxide, a significant portion of that gas dissolves into the world's oceans, leading to a chemical reaction that lowers the pH of seawater. This process, known as ocean acidification, poses a serious threat to marine ecosystems, which are essential to the health of the planet and to human populations living in coastal safe zones. Coral reefs, often referred to as the rainforests of the sea, are among the most vulnerable ecosystems to acidification. These reefs support an enormous variety of marine life and provide food and livelihoods for millions of people worldwide. However, as the ocean becomes more acidic, the calcium carbonate structures that make up coral reefs become weaker, making it harder for corals to grow and maintain their skeletons. This has led to widespread coral bleaching, where corals lose the symbiotic algae that provide them with energy, often leading to their death. The collapse of coral reefs would have profound consequences for marine biodiversity and for human societies that depend on healthy ocean ecosystems. Fish populations that rely on coral reefs for habitat would decline, impacting global fisheries and food security. In addition, coastal communities that rely on reefs for protection from storms and erosion would face increased risks as these natural barriers disappear. Beyond coral reefs, ocean acidification also affects other marine organisms, particularly those that rely on calcium carbonate to form shells and skeletons. Mollusks, crustaceans, and some types of plankton are struggling to maintain their shells in increasingly acidic waters, which threatens the base of the marine food chain. As these organisms decline, the entire ocean ecosystem is thrown off balance, with ripple effects that could impact global food supplies. The degradation of marine safe zones due to ocean acidification is a stark reminder of the interconnectedness of Earth's systems. What happens in the atmosphere does not stay in the atmosphere. It affects the oceans, the land, and all living creatures. As acidification progresses, the resilience of marine safe zones will continue to erode, with potentially devastating consequences for human civilization. Biodiversity, the variety of life on Earth, plays a critical role in maintaining the health and stability of ecosystems, including those that form the backbone of Earth's safe zones. Healthy ecosystems provide essential services such as clean air and water, fertile soil for agriculture, and pollination for crops. They also serve as natural buffers against extreme weather events and climate change. However, human activities, including deforestation, habitat destruction, and pollution, are driving a massive decline in biodiversity, which threatens to destabilize safe zones across the globe. The loss of biodiversity is particularly concerning because it reduces the resilience of ecosystems to environmental changes. In a highly diverse ecosystem, different species perform various roles that support the system's overall health. For example, in a forest ecosystem, some species of trees may be more resistant to drought, while others are more resilient to pests or disease. If one species declines, others can often fill the gap, maintaining the ecosystem's function. But as biodiversity diminishes, this redundancy disappears, leaving ecosystems more vulnerable to collapse. Forests, wetlands, and grasslands, key components of Earth's safe zones, are under intense pressure from human activity. The Amazon rainforest, which contains an estimated 10% of the planet's known biodiversity, is being deforested at an alarming rate to make way for agriculture and mining. This deforestation not only reduces biodiversity, but also releases large amounts of carbon dioxide into the atmosphere, further exacerbating climate change. Similar trends are occurring in other critical ecosystems, from the tropical rainforests of Southeast Asia to the boreal forests of Canada and Russia. The decline of pollinators such as bees and other insects is another alarming indicator of biodiversity loss. Pollinators are essential for the reproduction of many crops, including fruits, vegetables, and nuts, which form the basis of the global food supply. As pollinator populations decline due to habitat loss, pesticide use, and climate change, the stability of agricultural safe zones is threatened. Without adequate pollination, crop yields will decrease, leading to food shortages and economic instability. The collapse of biodiversity is a crisis that extends beyond individual species. It is a threat to the very systems that support life on Earth. As biodiversity continues to decline, Earth's safe zones will lose their ability to provide the essential services that humans depend on, pushing us closer to the edge of environmental collapse. Imagine waking up one morning in a world where the ecosystem services that humanity has long taken for granted have suddenly disappeared. Clean air is no longer a given. The forests that once filtered carbon dioxide are gone. Fresh water is scarce because wetlands and rivers, which once stored and filtered water, have been destroyed. Crops fail because pollinators have vanished, and without them, fruit and vegetable production plummets. In this scenario, the very foundations of human civilization begin to crumble. Without ecosystem services, we are forced to rely on technology to replace what nature once provided for free. Massive water purification plants, costly artificial pollination methods, and advanced carbon capture technologies become the norm. But these solutions come at a steep cost, both financially and environmentally. Moreover, they are not foolproof, and as natural systems continue to degrade, human societies face increasing instability. As we explore this thought experiment, the reality becomes clear. Earth's ecosystems are the ultimate safe zones, providing the services necessary for life to thrive. When these systems collapse, so too does human civilization. As this chapter draws to a close, we are left with the sobering realization that Earth's safe zones, once thought to be resilient and unshakable, are crumbling under the weight of human activity and climate change. From the melting of polar ice and the acidification of oceans to the loss of biodiversity and the decline of ecosystem services, the signs of collapse are all around us. Yet, there is still hope. By recognizing the urgency of the situation and taking bold action to protect and restore Earth's natural systems, we can slow or even reverse some of the damage. In the chapters that follow, we will explore the steps that can be taken to preserve the remaining safe zones, adapt to the changes already underway, and chart a path toward a more sustainable future. The human footprint, unsustainable growth and its consequences. Over the last century, the human population has exploded, increasing from just over 1.5 billion people in the early 1900s to over 7 billion today. As our numbers have grown, so too has our impact on the planet, stretching Earth's ecosystems to their limits. This exponential growth has placed immense pressure on the remaining safe zones, leading to resource depletion, habitat destruction, and environmental degradation. The challenge lies in the fact that as population grows, so does the demand for resources: food, water, energy, and land. More land is cleared for agriculture and urban development. Forests are logged, wetlands drained, and water diverted to support ever-expanding populations. In regions like sub-Saharan Africa, Southeast Asia, and Central America, high population growth rates are placing incredible pressure on ecosystems that are already struggling due to deforestation and climate change. In urban areas, particularly megacities like Delhi, São Paulo, and Lagos, the strain is especially visible. Overcrowding, poor infrastructure, and pollution make these cities increasingly vulnerable to environmental shocks like flooding, heat waves, and disease outbreaks. The safe zones in and around these urban centers are rapidly disappearing as natural spaces are replaced by concrete and steel, leaving populations more exposed to the consequences of environmental change. Globally, the rate of resource consumption far exceeds Earth's ability to regenerate those resources. As the Global Footprint Network has pointed out, humanity is currently using resources at a rate that would require the equivalent of 1.5 to 2 planets to sustain. This overshoot is unsustainable, and as population continues to grow, the strain on Earth's safe zones will only intensify. As human populations grow, so does the need for food. Agricultural expansion has been one of the primary drivers of environmental degradation over the past century. The conversion of forests, grasslands, and wetlands into croplands and pastures has resulted in the destruction of ecosystems that once served as natural safe zones for biodiversity and human life alike. But while industrial agriculture has allowed for the production of large quantities of food, it has also come with significant environmental costs. Modern agriculture relies heavily on chemical fertilizers, pesticides, and water-intensive irrigation practices. These methods, while effective in the short term, have long-term consequences for soil health, water resources, and biodiversity. Over time, the excessive use of chemical inputs depletes soil fertility, leading to desertification and reduced agricultural productivity. This degradation is particularly pronounced in regions like sub-Saharan Africa, where unsustainable farming practices have contributed to the expansion of deserts. Water scarcity is another critical issue exacerbated by agricultural practices. According to the Food and Agriculture Organization, FAO, agriculture accounts for approximately 70% of global freshwater use. In arid regions, such as parts of the Middle East, North Africa, and the American Southwest, water resources are being rapidly depleted to support irrigation for crops like cotton, wheat, and corn. This over-extraction of water is leading to the depletion of underground aquifers and the drying up of rivers and lakes, further reducing the resilience of these regions. The deforestation of the Amazon rainforest, often referred to as the lungs of the planet, is a prime example of agricultural expansion's environmental toll. The Amazon is being cleared at an alarming rate to make way for cattle ranching and soy production. This destruction not only contributes to climate change by releasing vast amounts of carbon dioxide into the atmosphere, but also leads to the loss of biodiversity and the disruption of indigenous communities that depend on the forest for their livelihoods. Agricultural expansion is, therefore, a double-edged sword. While it is necessary to feed a growing population, it is also contributing to the collapse of Earth's safe zones. The challenge moving forward will be to find ways to produce enough food for humanity while protecting the ecosystems that sustain life. Energy consumption is another major factor in the degradation of Earth's safe zones. The modern world is powered primarily by fossil fuels, coal, oil, and natural gas, which have fueled industrialization, transportation, and electricity generation for over a century. But the environmental costs of this reliance on fossil fuels are becoming increasingly apparent. The burning of fossil fuels is the leading cause of greenhouse gas emissions, which are driving global climate change. Carbon dioxide, methane, and nitrous oxide are released into the atmosphere when fossil fuels are burned, trapping heat and causing the planet to warm. This warming is destabilizing weather patterns, melting polar ice, raising sea levels, and increasing the frequency of extreme weather events, all of which threaten Earth's safe zones. In addition to contributing to climate change, fossil fuel extraction and use have direct environmental impacts. Oil spills, coal mining, and hydraulic fracturing, fracking, are associated with habitat destruction, water contamination, and air pollution. The 2010 Deepwater Horizon oil spill in the Gulf of Mexico, for example, devastated marine ecosystems and local economies, highlighting the risks associated with oil drilling. Similarly, mountaintop removal mining in Appalachia has caused irreversible damage to forests and rivers, displacing communities and destroying habitats. Despite these environmental costs, global demand for energy continues to rise. According to the International Energy Agency, IEA, global energy consumption is expected to increase by over 25% by the middle of this century, driven largely by population growth and economic development in emerging economies. This rising demand will put even greater pressure on Earth's safe zones, especially if fossil fuels continue to dominate the global energy mix. To mitigate these impacts, a transition to renewable energy sources, such as wind, solar, and geothermal power, is urgently needed. Renewable energy technologies offer the potential to provide clean, sustainable energy without the environmental costs associated with fossil fuels. However, the pace of this transition has been slow, and in many parts of the world, fossil fuels remain the primary source of energy. Accelerating the shift to renewables will be critical for preserving Earth's safe zones and stabilizing the climate. The global trend of urbanization is one of the most significant demographic shifts of the 21st century. Today, over half of the world's population lives in urban areas, and that figure is expected to rise to nearly 70% by the middle of this century. As cities expand, natural safe zones, forests, wetlands, grasslands, are being replaced with concrete and asphalt, contributing to the loss of biodiversity, the fragmentation of ecosystems, and the depletion of natural resources. Urbanization is often seen as a driver of economic growth and modernization, but it comes at a steep environmental cost. Cities are energy-intensive, relying on vast amounts of electricity, water, and food to support their populations. They also generate large quantities of waste and pollution, which can have far-reaching effects on the surrounding environment. In many cases, urban expansion leads to the destruction of the very ecosystems that provide essential services to city dwellers, such as clean air and water. One of the most visible consequences of urbanization is the heat island effect, where urban areas become significantly warmer than their rural surroundings due to the concentration of buildings, roads, and other infrastructure that absorb and retain heat. This phenomenon exacerbates the impacts of climate change, making cities more vulnerable to heat waves and increasing the demand for air conditioning and energy. Coastal cities are particularly vulnerable to the impacts of climate change as they face the dual threats of rising sea levels and more intense storms. Cities like New York, Miami, Tokyo, and Jakarta are already grappling with flooding and storm surges, which are expected to become more frequent and severe as the planet warms. In low-lying areas, such as parts of Bangladesh and the Maldives, entire communities may be forced to relocate as their homes become uninhabitable. Urban sprawl, the uncontrolled expansion of cities into rural areas, is also a major driver of habitat loss and ecosystem fragmentation. As cities spread out, they encroach on forests, wetlands, and farmland, reducing the space available for wildlife and agriculture. This loss of natural safe zones not only threatens biodiversity, but also undermines the resilience of ecosystems that provide critical services, such as flood control, carbon sequestration, and water purification. To address these challenges, cities will need to adopt more sustainable urban planning practices that prioritize the preservation of natural safe zones and the reduction of environmental impacts. Green infrastructure such as parks, green roofs, and wetlands can help cities manage stormwater, reduce heat, and provide habitat for wildlife. Compact, walkable urban designs can reduce energy consumption and reliance on cars, while also improving the quality of life for residents. Let's conduct a thought experiment. Imagine a world where fossil fuels have been completely phased out. There are no oil rigs drilling in the ocean, no coal-fired power plants belching smoke into the air, and no gasoline-powered cars on the road. Instead, the world is powered entirely by renewable energy sources, solar panels, wind turbines, geothermal plants, and tidal generators. In this world, energy is clean, abundant, and sustainable. But transitioning to this future would not be easy. In the early stages of the transition, there would likely be significant disruptions to global economies and energy systems. Fossil fuels are deeply embedded in nearly every aspect of modern life, from transportation and manufacturing to electricity generation and heating. Phasing out these energy sources would require massive investments in new infrastructure, as well as changes in how we live, work, and travel. In this thought experiment, humanity would need to reimagine the way cities are built, how goods are transported, and how food is grown. Large-scale renewable energy farms would replace fossil fuel power plants, while electric vehicles would dominate the roads. Buildings would be designed to be energy efficient, using natural light and ventilation to reduce the need for heating and cooling. Agriculture would rely on sustainable practices that conserve water and protect soil health, rather than industrial-scale monocultures. The benefits of this transition would be immense. Carbon emissions would plummet, slowing the pace of climate change and reducing the risk of extreme weather events. Air and water quality would improve, leading to better health outcomes for millions of people. Natural ecosystems would begin to recover as the pressure from fossil fuel extraction and pollution is lifted. However, the transition would also pose significant challenges, particularly for regions and industries that are heavily dependent on fossil fuels. Jobs in coal mining, oil drilling, and gas production would disappear, and entire communities could be economically devastated. Managing this transition in a way that is equitable and just will be one of the greatest challenges of the 21st century. As we conclude this chapter, it becomes clear that humanity's growth, both in population and in resource consumption, is placing unsustainable pressure on Earth's safe zones. From agricultural expansion and fossil fuel addiction to urbanization and habitat destruction, our impact on the planet is pushing ecosystems to the brink of collapse. The consequences of this unsustainable growth are already being felt, and they will only intensify in the coming decades unless urgent action is taken. The next chapter will explore the potential solutions to these challenges, focusing on the ways in which technology, policy, and individual action can help preserve Earth's remaining safe zones and create a more sustainable future for humanity. As the final countdown to environmental collapse continues, it is up to us to determine the fate of our planet and the safe zones that sustain life. Technological solutions and innovations for preserving Earth's safe zones. In the face of mounting environmental challenges, the transition to renewable energy stands out as one of the most promising solutions for preserving Earth's safe zones. Unlike fossil fuels, which release carbon dioxide and other harmful pollutants into the atmosphere, renewable energy sources like solar, wind, geothermal, and hydropower produce clean energy with minimal environmental impact. By reducing our reliance on fossil fuels, we can slow the pace of climate change, protect natural ecosystems, and create a more sustainable future. Solar power, in particular, has seen rapid advancements in recent years, becoming more efficient and affordable. Solar panels convert sunlight into electricity using photovoltaic cells, and recent breakthroughs have made these cells more efficient at capturing energy even in low-light conditions. Solar energy can be harnessed at both large and small scales, from vast solar farms to rooftop panels on individual homes. With the cost of solar technology continuing to decline, it is becoming increasingly accessible to both developed and developing countries. Wind power is another key player in the renewable energy revolution. Wind turbines generate electricity by capturing the kinetic energy of moving air. Offshore wind farms, located in areas with consistently strong winds, have the potential to generate large amounts of electricity with minimal environmental disruption. Onshore wind farms, too, are becoming more widespread, particularly in regions with vast open landscapes, such as the American Midwest and parts of Europe. Geothermal energy, which harnesses the heat from beneath the Earth's surface, offers another reliable and clean source of power. In areas where geothermal activity is high, such as Iceland and parts of the Pacific Ring of Fire, geothermal plants provide a steady source of energy with minimal emissions. Hydropower, which generates electricity from the flow of water, is already a major source of renewable energy in many parts of the world, though care must be taken to manage its impact on river ecosystems. While the global transition to renewable energy is underway, there are still significant challenges to overcome. One of the biggest hurdles is the intermittent nature of some renewable energy sources, such as solar and wind. Energy storage solutions, like advanced battery technology, will be critical for ensuring that renewable energy can provide a consistent supply of electricity, even when the sun isn't shining or the wind isn't blowing. Another challenge is the need for massive infrastructure investments to support renewable energy generation, particularly in developing countries that may lack the resources to make this transition on their own. Despite these challenges, the shift to renewable energy is essential for preserving Earth's safe zones and mitigating the effects of climate change. As the technology continues to advance, renewable energy will play an increasingly important role in powering a sustainable future. As the global population continues to grow, so does the demand for food. However, traditional agricultural practices, characterized by monocultures, chemical inputs, and deforestation, are contributing to the degradation of safe zones around the world. Sustainable agriculture offers a path forward, one that balances the need to feed the world with the need to protect the environment. One of the most promising approaches to sustainable agriculture is regenerative farming, which focuses on restoring soil health and biodiversity. Unlike conventional farming, which often depletes the soil of nutrients and contributes to erosion, regenerative practices aim to build soil fertility through techniques like crop rotation, cover cropping, and composting. These methods not only increase agricultural productivity, but also help sequester carbon in the soil, reducing greenhouse gas emissions and enhancing the resilience of ecosystems. Agroforestry, the practice of integrating trees and shrubs into agricultural landscapes, is another powerful tool for sustainable farming. Trees provide shade, reduce wind erosion, and help retain soil moisture, all of which improve crop yields and protect the land. In tropical regions, agroforestry systems mimic natural forests, providing a habitat for wildlife while producing food, fuel, and other resources for local communities. By preserving biodiversity and maintaining ecosystem services, agroforestry helps to stabilize safe zones and prevent environmental collapse. Precision agriculture, which uses technology to optimize farming practices, is also gaining traction as a way to increase efficiency and reduce environmental impact. Sensors, drones, and satellite imagery can provide real-time data on soil health, moisture levels, and crop growth, allowing farmers to make informed decisions about when and where to apply water, fertilizers, and pesticides. This targeted approach minimizes waste and reduces the use of harmful chemicals, protecting both the environment and human health. In addition to these practices, the development of alternative proteins, such as lab-grown meat and plant-based substitutes, could play a crucial role in reducing the environmental impact of food production. Traditional livestock farming is a major driver of deforestation, methane emissions, and water consumption. By shifting to more sustainable protein sources, we can reduce the strain on Earth's safe zones and protect ecosystems from further degradation. The challenge of feeding a growing global population without destroying the environment is immense, but sustainable agriculture offers a way forward. By adopting practices that restore soil health, conserve water, and protect biodiversity, we can create a food system that nourishes both people and the planet. One of the most effective ways to mitigate the impacts of climate change and environmental degradation is through reforestation and ecosystem restoration. Forests, wetlands, grasslands, and coral reefs are essential components of Earth's safe zones, providing habitat for wildlife, storing carbon, and regulating water cycles. However, many of these ecosystems have been severely damaged or destroyed by human activities. Rebuilding these ecosystems is critical for preserving biodiversity, stabilizing the climate, and protecting human communities from environmental disasters. Reforestation, planting trees to restore degraded or deforested areas, has emerged as a powerful tool for combating climate change. Trees act as natural carbon sinks, absorbing carbon dioxide from the atmosphere and storing it in their biomass. Large-scale reforestation projects, such as the Bond Challenge and the Trillion Trees Initiative, aim to restore millions of hectares of forest around the world, helping to offset carbon emissions and provide vital ecosystem services. In addition to reforestation, ecological restoration focuses on reviving entire ecosystems, not just individual species. Wetland restoration, for example, involves re-establishing the natural flow of water and planting native vegetation to create habitats for fish, birds, and other wildlife. Wetlands are crucial for flood control, water purification, and carbon sequestration, making their restoration a priority in regions vulnerable to climate change impacts. Grassland restoration is another important effort, particularly in regions like the American Great Plains and the African savannas, where overgrazing and agriculture have degraded vast areas. Restoring native grasses and managing livestock in sustainable ways can help prevent soil erosion, improve water retention, and support biodiversity. Healthy grasslands also store significant amounts of carbon, making them important allies in the fight against climate change. Coral reef restoration is an emerging field that aims to reverse the damage caused by climate change, pollution, and overfishing. Coral reefs are among the most biodiverse ecosystems on the planet, providing food and livelihoods for millions of people. However, rising ocean temperatures and acidification have led to widespread coral bleaching, threatening the future of these ecosystems. Restoration efforts involve transplanting healthy corals, breeding more resilient species, and reducing local stressors like pollution and overfishing. The restoration of Earth's safe zones is not just an environmental imperative, it is also a moral one. By restoring ecosystems, we not only protect the planet's biodiversity, but also create healthier, more resilient communities for future generations. Rebuilding nature's safe zones will require a global commitment and collaboration across sectors, but the rewards, both ecological and social, are immense. What is all this fuss about carbon capture and geoengineering? All the information around it seems to be controversial, but necessary. Is that in itself true? As the impacts of climate change become more severe, some scientists and policymakers are turning to more radical solutions, such as carbon capture and geoengineering, to mitigate the damage. Carbon capture and storage, CCS, refers to the process of capturing carbon dioxide emissions from industrial sources and storing them underground, preventing the gas from entering the atmosphere. While CCS has the potential to reduce emissions from power plants and factories, it is still a relatively new technology with significant challenges, including high costs and concerns about long-term storage safety. Direct air capture, DAC, a related technology, involves capturing carbon dioxide directly from the atmosphere and either storing it or using it in industrial processes. While DAC is more expensive and energy-intensive than other methods of carbon reduction, it could play a critical role in reducing atmospheric carbon concentrations in the future, especially if emissions continue to rise. Geoengineering, the deliberate manipulation of the Earth's climate, is another controversial option being explored as a potential solution to global warming. One proposed method is solar radiation management, SRM, which involves reflecting a small portion of the sun's energy back into space to cool the planet. This could be achieved by injecting aerosols into the stratosphere, similar to how volcanic eruptions cool the planet by blocking sunlight. While SRM could theoretically reduce global temperatures, it does not address the root cause of climate change, greenhouse gas emissions, and could have unintended consequences, such as disrupting weather patterns and reducing rainfall. Ocean fertilization, another geoengineering concept, involves adding nutrients like iron to the ocean to stimulate the growth of phytoplankton, which absorb carbon dioxide during photosynthesis. While this could help sequester carbon, it also risks creating dead zones by depleting oxygen levels in the water and disrupting marine ecosystems. The ethical and environmental risks of geoengineering are significant, and many scientists argue that it should only be considered as a last resort if other efforts to reduce emissions fail. Nevertheless, as the climate crisis worsens, these technologies are likely to become part of the global conversation about how to preserve Earth's safe zones and stabilize the climate. Let's engage in a thought experiment. Imagine a future where humanity has successfully deployed geoengineering technologies to stabilize the climate. The average global temperature is held in check by a combination of solar radiation management, carbon capture, and ocean fertilization. Natural disasters such as heat waves, hurricanes, and floods have become less frequent and less severe. It seems as though we have finally gained control over Earth's climate. But what are the unintended consequences of this technologically engineered climate? Have we solved one problem only to create new ones? For example, what happens to ecosystems that rely on natural seasonal cycles, which may be disrupted by solar radiation management? How do we ensure that geoengineering technologies do not exacerbate inequality, with wealthier nations benefiting at the expense of poorer ones? And what if these technologies fail or are used irresponsibly? In this thought experiment, the world faces a moral and ethical dilemma. While geoengineering may provide temporary relief from the worst impacts of climate change, it also comes with significant risks. This experiment highlights the importance of using technology wisely and cautiously, recognizing that some problems, like climate change, are best addressed at their root rather than through technological quick fixes. As we conclude this chapter, it is clear that technology offers powerful tools for addressing the environmental challenges facing Earth's safe zones. Renewable energy, sustainable agriculture, ecosystem restoration, and even controversial technologies like carbon capture and geoengineering all have roles to play in creating a more sustainable future. However, technology alone will not solve the problems of environmental degradation and climate change. It must be coupled with a commitment to reducing consumption, protecting natural ecosystems, and promoting social and environmental justice. In the chapters that follow, we will explore the role of policy, governance, and individual action in preserving Earth's safe zones. While technology is an essential part of the solution, it is ultimately human decisions at both the global and local levels that will determine the future of our planet. Global policy and governance shaping the future of Earth's safe zones. Addressing the global environmental crisis requires international cooperation on a scale never before seen in human history. Climate change, deforestation, ocean degradation, and biodiversity loss are all transboundary issues that cannot be tackled by individual nations alone. The Paris Agreement, adopted in December 2015, represents one of the most significant global efforts to address climate change, with nearly 200 countries committing to limiting global temperature rise to below 2 degrees Celsius above pre-industrial levels, and ideally to 1.5 degrees. The Paris Agreement is built on a framework of voluntary, nationally determined contributions, NDCs, in which each country sets its own goals for reducing greenhouse gas emissions. These commitments are reviewed and updated every 5 years, with the aim of increasing ambition over time. While the agreement represents a major step forward in the global fight against climate change, its voluntary nature means that there are no binding penalties for countries that fail to meet their targets. Since the adoption of the Paris Agreement, many countries have made significant progress in reducing their emissions and transitioning to renewable energy. However, global emissions have continued to rise, and recent reports from the Intergovernmental Panel on Climate Change, IPCC, indicate that the world is not on track to meet the 1.5-degree target. The challenge now is to increase the ambition of the Paris Agreement by encouraging countries to set more aggressive targets, while also ensuring that financial and technological support is provided to developing nations that may lack the resources to meet their goals. In addition to the Paris Agreement, other international agreements play crucial roles in protecting Earth's safe zones. The Convention on Biological Diversity, CBD, for example, aims to conserve biodiversity, promote sustainable use of natural resources, and ensure the fair and equitable sharing of benefits arising from the use of genetic resources. The United Nations Convention to Combat Desertification, UNCCD, focuses on addressing land degradation and desertification, particularly in dryland regions that are home to some of the world's most vulnerable populations. These agreements, while imperfect, provide the legal and institutional frameworks needed to address global environmental challenges. However, their success depends on the political will of individual nations, as well as the ability of the international community to enforce compliance and support capacity-building efforts in developing countries. As the impacts of climate change and environmental degradation become more severe, the issue of climate justice is gaining prominence in global discussions. Climate justice recognizes that the people and countries most affected by environmental destruction are often the least responsible for causing it. Low-income communities, indigenous peoples, and small island nations are disproportionately vulnerable to the effects of rising sea levels, extreme weather events, and biodiversity loss, even though they have contributed relatively little to the problem. For example, small island nations in the Pacific, such as Kiribati and the Maldives, face the existential threat of rising sea levels. Despite their minimal contributions to global greenhouse gas emissions, these countries are among the first to experience the devastating consequences of climate change. In response, many small island nations have become vocal advocates for more ambitious global climate action, calling on larger, more industrialized nations to take responsibility for their historical emissions and provide financial and technical support for adaptation and resilience building. Indigenous communities, too, are often on the front lines of environmental degradation. Many indigenous peoples depend on their local ecosystems for food, water, and cultural practices, making them particularly vulnerable to the destruction of forests, rivers, and biodiversity. At the same time, indigenous communities have long been stewards of the land, with deep knowledge of sustainable practices that can help restore and protect ecosystems. Climate justice demands that indigenous voices be included in decision-making processes and that their rights to land, resources, and self-determination be respected. The concept of a just transition is central to the climate justice movement. A just transition seeks to ensure that the shift to a low-carbon economy does not leave workers and communities behind, particularly those in industries like coal, oil, and gas, which will see job losses as fossil fuels are phased out. Policies to support workers in transitioning to new industries through retraining programs, social safety nets, and investments in green jobs are essential for ensuring that the benefits of climate action are shared equitably. International agreements like the Paris Agreement have recognized the importance of climate justice by including provisions for climate finance, adaptation, and loss and damage. Wealthier nations have committed to providing financial support to developing countries to help them adapt to the impacts of climate change and transition to sustainable economies. However, fulfilling these commitments has been slow, and many developing nations argue that the funds provided so far are insufficient to meet the scale of the challenge. Are national policies leading by example or falling short? While international agreements provide a framework for global action, it is ultimately up to individual countries to implement policies that protect Earth's safe zones. Some countries have emerged as leaders in the fight against climate change and environmental degradation, while others have been slow to act or have actively undermined global efforts. In Europe, several countries have made significant progress in reducing emissions and transitioning to renewable energy. Germany's Energiewende, energy transition policy, for example, has led to a substantial increase in renewable energy generation, particularly from wind and solar power. Denmark, too, has become a global leader in wind energy, with nearly half of its electricity coming from wind turbines. These countries have set ambitious goals for achieving carbon neutrality by mid-century and are investing heavily in green technologies and infrastructure. In contrast, some of the world's largest emitters, such as the United States and China, have had more mixed records. While both countries have made significant strides in renewable energy, particularly in solar and wind, they remain heavily reliant on fossil fuels. The United States, in particular, has faced political divisions over climate policy, with successive administrations taking drastically different approaches to international agreements like the Paris Accord. China, as the world's largest emitter of greenhouse gases, has announced its intention to achieve carbon neutrality by 2060, but its continued reliance on coal presents a major obstacle to meeting this goal. In the developing world, countries like Costa Rica have become environmental pioneers. Costa Rica has pledged to become carbon neutral by 2050 and has already made significant progress by generating nearly all of its electricity from renewable sources. The country has also implemented ambitious reforestation programs and established vast protected areas to conserve its rich biodiversity. Costa Rica's success demonstrates that even small, developing nations can lead by example when it comes to environmental protection. However, many developing countries face significant challenges in implementing strong environmental policies. Poverty, political instability, and a lack of financial and technological resources can make it difficult for these nations to prioritize climate action. This is where international cooperation and climate finance become essential, as wealthier nations must step up to provide the support needed to help vulnerable countries protect their safe zones and adapt to the changing climate. While national and international policies are critical for addressing large-scale environmental challenges, local governance and grassroots movements often play an equally important role in protecting Earth's safe zones. Around the world, communities are taking action to restore ecosystems, combat pollution, and build resilience to climate change. These local efforts are essential for implementing global goals on the ground and ensuring that solutions are tailored to the specific needs of local environments and populations. One powerful example of grassroots action is the global movement for urban farming and community gardens. In cities around the world, local residents are reclaiming vacant lots and unused spaces to grow food, promote biodiversity, and create green spaces. These projects not only provide fresh, healthy produce for urban communities, but also help reduce the urban heat island effect, improve air quality, and foster a sense of community. In cities like Detroit, where economic decline has left large swaths of land vacant, urban farming has become a symbol of resilience and renewal. In rural areas, indigenous-led conservation initiatives have been particularly effective at protecting biodiversity and restoring ecosystems. In the Amazon rainforest, for example, indigenous communities have successfully resisted deforestation and illegal logging by enforcing their territorial rights and managing the land according to traditional practices. Research has shown that indigenous managed forests are often better preserved than those managed by national governments or private corporations, underscoring the importance of indigenous leadership in environmental conservation. Local governments, too, can play a crucial role in shaping environmental policy. Many cities have set ambitious climate goals, even when national governments have been slow to act. The C40 Cities Network, for example, brings together mayors from nearly 100 cities around the world to collaborate on reducing emissions, improving air quality, and building resilience to climate change. Cities like Copenhagen, New York, and Seoul have set targets for achieving carbon neutrality, implementing policies that promote public transportation, renewable energy, and green building practices. At the heart of these grassroots and local efforts is the recognition that environmental action must be inclusive and equitable. Community-led solutions are often more effective because they reflect the specific needs and values of the people they serve. By empowering local communities to take ownership of their environmental future, we can ensure that solutions are not imposed from the top down, but are built from the ground up. Imagine a world where every nation, every city, and every community prioritizes environmental stewardship in every decision they make. Governments at all levels work together to implement policies that protect natural ecosystems, promote sustainable development, and ensure equity and justice for all people. Renewable energy powers the global economy. Forests and wetlands are restored to their former glory, and biodiversity flourishes across the planet. In this world, local communities play a central role in environmental governance. Indigenous knowledge is integrated into national conservation strategies, and grassroots movements lead the charge in restoring ecosystems and building resilience to climate change. Cities are green and vibrant, with parks, gardens, and renewable energy infrastructure integrated into every neighborhood. But how would such a world be achieved? Would it require a radical shift in how we think about governance, economy, and society? What sacrifices would need to be made, and what new systems of collaboration would emerge? This thought experiment invites us to imagine what is possible if humanity truly commits to environmental stewardship as a guiding principle. As we conclude this chapter, it is clear that policy and governance are critical components of the effort to preserve Earth's safe zones. International agreements, like the Paris Accord, provide the framework for global action, but the success of these efforts depends on the political will of individual nations, the inclusion of vulnerable communities, and the empowerment of local actors. The next chapter will explore the role of individual action and how each of us can contribute to the preservation of Earth's safe zones. While policy and governance are essential, the choices we make as individuals, how we consume, how we travel, and how we live, will also shape the future of the planet. The power of individual action, personal responsibility, and collective change. As global environmental challenges grow more urgent, there is an increasing recognition that individual actions can make a significant difference in the fight to preserve Earth's safe zones. Each person's lifestyle choices contribute to the planet's overall health, and by making conscious decisions to reduce our carbon footprint, we can collectively steer society toward a more sustainable future. A carbon footprint refers to the total amount of greenhouse gases, primarily carbon dioxide, that an individual, organization, or activity emits directly or indirectly. This includes everything from the energy we use to heat our homes, the fuel we burn while driving, and the food we consume. The average carbon footprint per person varies widely by country, with those in wealthier, industrialized nations often having much larger footprints than those in developing countries. The first step in reducing one's carbon footprint is understanding the primary sources of personal emissions. For most individuals, transportation, energy use, and diet are the biggest contributors. In countries where car ownership is widespread, driving is one of the largest sources of emissions. Air travel, too, is a major source of carbon pollution, with a single long-haul flight producing more emissions than many people in developing countries generate in an entire year. Home energy use is another significant source of emissions, particularly in regions that rely on fossil fuels for electricity and heating. In many parts of the world, homes are heated by burning oil or gas, and electricity is generated from coal or natural gas. Even seemingly innocuous activities like using a clothes dryer, leaving lights on, or setting the thermostat too high can significantly increase an individual's carbon footprint. Food production also plays a surprisingly large role in personal carbon emissions. The global food system, especially the production of meat and dairy products, generates a significant amount of greenhouse gases. Livestock farming is responsible for methane emissions, which have a much higher warming potential than carbon dioxide. In addition, the transportation, refrigeration, and packaging of food all contribute to the carbon footprint of the average consumer. By understanding the key drivers of our individual carbon footprints, we can take meaningful steps to reduce our impact. While it may seem that individual actions are too small to make a difference on a global scale, when millions of people make similar changes, the collective impact can be transformative. Transportation is one of the biggest contributors to individual carbon footprints, and it's also an area where small changes can have a significant impact. One of the most effective ways to reduce transportation-related emissions is by choosing to walk, bike, or use public transportation instead of driving a personal vehicle. These alternatives not only reduce emissions, but also contribute to healthier, more vibrant communities. For those who rely on a car for daily commuting or errands, choosing a fuel-efficient vehicle or switching to an electric vehicle, EV, can drastically reduce carbon emissions. Electric cars produce no tailpipe emissions and, when powered by renewable energy, offer a truly sustainable alternative to gasoline-powered vehicles. Governments around the world are increasingly offering incentives for EV purchases, as well as building out charging infrastructure to support widespread adoption. Carpooling and ride-sharing services also offer a simple way to reduce emissions by sharing the journey with others. By reducing the number of vehicles on the road, carpooling not only lowers emissions, but also helps alleviate traffic congestion and reduce air pollution in cities. For long-distance travel, air travel remains one of the most carbon-intensive modes of transportation. While some airlines are beginning to invest in more fuel-efficient aircraft and sustainable aviation fuels, the best way to reduce emissions from flying is simply to fly less. Opting for trains or buses when possible, particularly for shorter distances, can significantly cut travel-related emissions. In Europe, high-speed rail networks offer an efficient, low-carbon alternative to flying, and similar initiatives are gaining traction in other parts of the world. At the policy level, governments can encourage more sustainable transportation options by investing in public transit infrastructure, expanding bike lanes, and incentivizing the adoption of electric vehicles. However, individual decisions, whether to walk, bike, drive, or fly, remain critical in reducing transportation-related emissions and preserving Earth's safe zones. What we eat has a profound impact on the environment, and making more sustainable food choices is one of the most powerful ways individuals can reduce their carbon footprint. The global food system is responsible for approximately 1/4 of the world's greenhouse gas emissions, with the production of meat, dairy, and other animal products being some of the largest contributors. In addition to emitting methane and carbon dioxide, industrial livestock farming consumes vast amounts of water, land, and feed crops, contributing to deforestation and biodiversity loss. One of the most effective ways to reduce the environmental impact of our diets is by consuming less meat, particularly beef and lamb, which have the highest carbon footprints of any food products. Shifting toward a more plant-based diet, rich in fruits, vegetables, grains, and legumes, can significantly reduce greenhouse gas emissions, while also offering health benefits such as lower rates of heart disease and obesity. For those who are not ready to give up meat entirely, reducing meat consumption through practices like Meatless Mondays or choosing sustainably sourced meats can still make a difference. Supporting local farmers and buying seasonal produce can also help reduce the carbon footprint of food by cutting down on the emissions associated with transportation and refrigeration. Food waste is another major contributor to emissions. Approximately 1/3 of all food produced globally is lost or wasted, and when food ends up in landfills, it decomposes and releases methane, a potent greenhouse gas. Reducing food waste by planning meals carefully, storing food properly, and using leftovers can prevent unnecessary emissions and save money. By making more sustainable food choices, individuals can contribute to the protection of Earth's safe zones by reducing the environmental pressure on land, water, and ecosystems. The cumulative effect of these choices, made by millions of people, has the potential to reshape the global food system for the better. Energy use in homes and buildings accounts for a significant portion of individual carbon footprints. However, there are many ways to reduce energy consumption, lower emissions, and save money at the same time. Energy-efficient homes not only contribute to reducing global greenhouse gas emissions, but also help households reduce their energy bills. One of the most effective ways to reduce home energy consumption is by improving insulation and sealing any air leaks. Proper insulation helps maintain a stable indoor temperature, reducing the need for heating and cooling. Similarly, upgrading to energy-efficient windows, doors, and appliances can cut down on electricity use and lower carbon emissions. Heating and cooling are among the largest energy consumers in most homes, so adjusting thermostat settings can have a big impact. In the winter, lowering the thermostat by just a few degrees can significantly reduce heating costs, while using fans or opening windows in the summer can reduce the need for air conditioning. Installing programmable thermostats or smart home systems can help optimize energy use, ensuring that heating and cooling systems are only active when needed. Switching to energy-efficient lighting, such as LED bulbs, is another simple but effective way to reduce electricity consumption. LED bulbs use a fraction of the energy required by traditional incandescent bulbs and last much longer, reducing both energy use and waste. For those looking to go even further, installing solar panels on homes or properties can provide clean, renewable energy and reduce reliance on fossil fuels. In many regions, government incentives and rebates are available to help offset the initial cost of solar installation. Battery storage systems, which store excess solar energy for use during cloudy days or at night, are becoming more affordable and offer additional flexibility for home energy management. Ultimately, improving energy efficiency at home not only helps individuals reduce their carbon footprint, but also contributes to reducing demand on the broader energy grid, enabling a faster transition to renewable energy sources on a global scale. Water is one of Earth's most valuable and limited resources, yet it is often taken for granted in many parts of the world. As climate change intensifies, water scarcity is becoming a pressing issue in regions that once had abundant freshwater supplies. Reducing water waste and conserving this precious resource is essential for protecting Earth's safe zones and ensuring that future generations have access to clean, reliable water. Simple actions, such as turning off the tap while brushing teeth, fixing leaky faucets, and using low-flow shower heads and toilets, can significantly reduce household water consumption. In areas where water is particularly scarce, rainwater harvesting systems can be installed to collect and store rainwater for gardening, flushing toilets, or even drinking, depending on the system. Reducing water waste in agriculture is also critical for protecting freshwater ecosystems. In many parts of the world, inefficient irrigation practices lead to massive water losses. Drip irrigation, which delivers water directly to the roots of plants, is a much more efficient method that can reduce water consumption by as much as 50%. Individuals can also contribute to water conservation by making conscious choices about the products they consume. Many items, such as clothing, food, and electronics, require large amounts of water to produce. For example, growing cotton for a single t-shirt can require thousands of liters of water. By choosing sustainable products, reducing consumption, and supporting businesses that prioritize water conservation, individuals can help protect the planet's limited freshwater resources. Let's conduct a thought experiment. Imagine a world where every individual, from the wealthiest countries to the most remote communities, made sustainable choices in their everyday lives. People drive electric vehicles, eat plant-based diets, live in energy-efficient homes, and conserve water wherever possible. Solar panels, wind turbines, and electric buses power cities, while forests, wetlands, and coral reefs thrive thanks to widespread efforts to restore natural ecosystems. In this world, individual actions are not seen as insignificant, but as part of a global movement toward sustainability. People understand that their choices matter, and governments, businesses, and communities work together to create a future where humanity lives in harmony with the Earth. The result is a planet where biodiversity flourishes, climate change is under control, and safe zones are preserved for future generations. This thought experiment highlights the potential for individual actions to drive collective change. While the global environmental crisis may seem overwhelming, each person has the power to contribute to the solution. By making sustainable choices, individuals can help build a more just, equitable, and resilient world for all. As we conclude this chapter, it is clear that individual actions, while seemingly small, have the potential to create a ripple effect that can transform societies and protect Earth's safe zones. From reducing carbon footprints and choosing sustainable diets to conserving water and improving energy efficiency, each of us has the power to make a difference. In the next chapter, we will explore the role of technology, innovation, and science in shaping the future of environmental conservation. While individual actions are critical, advances in technology and scientific discovery will play an equally important role in securing a sustainable future for humanity. Scientific innovation and technology, shaping the future of environmental conservation. Artificial intelligence, AI, is rapidly transforming many sectors of society, and its potential to protect and preserve Earth's safe zones is increasingly being recognized. AI has the ability to process vast amounts of data, identify patterns, and make predictions far more efficiently than human analysts. When applied to environmental challenges, AI can offer new insights, optimize conservation efforts, and improve decision-making in real time. One of the most promising applications of AI is in monitoring and managing natural ecosystems. Satellite imagery and remote sensing technologies have allowed us to gather unprecedented amounts of data about forests, oceans, and biodiversity. However, analyzing this data manually would be an immense and time-consuming task. AI can automate the analysis process, detecting changes in land use, deforestation rates, and wildlife populations far more quickly than traditional methods. This allows scientists and conservationists to respond to environmental threats more effectively, preventing or mitigating damage before it becomes irreversible. AI is also being used to combat illegal activities that threaten safe zones, such as poaching and illegal logging. In Africa, for example, AI-powered systems analyze data from motion-activated cameras and drones to detect poachers in real time, allowing park rangers to intercept them before they can harm endangered species. Similarly, AI can be used to monitor logging activities in tropical rainforests, alerting authorities when illegal deforestation is detected. In agriculture, AI-driven tools are helping farmers make more efficient use of water, fertilizers, and pesticides, reducing the environmental impact of food production. Precision agriculture technologies powered by AI allow farmers to monitor crop health, soil conditions, and weather patterns with incredible accuracy, ensuring that resources are used only where they are needed. This not only conserves water and reduces chemical runoff, but also increases crop yields, making food production more sustainable. AI can also play a role in optimizing renewable energy systems. In the case of wind and solar power, AI algorithms can predict weather patterns to maximize energy generation, helping grid operators balance supply and demand more effectively. As the renewable energy sector continues to grow, AI will become an essential tool for managing complex, decentralized energy grids and ensuring that clean energy is distributed efficiently. While AI offers exciting possibilities for environmental conservation, there are also challenges to consider. The development and deployment of AI systems require significant energy and computational resources, which can have their own environmental impacts. Ensuring that AI technologies are implemented in a way that minimizes their carbon footprint will be essential for realizing their potential as a tool for conservation. Biotechnology, particularly the field of genetic engineering, is emerging as a controversial yet potentially transformative tool for environmental conservation. Advances in gene editing technologies, such as CRISPR, have opened up new possibilities for addressing some of the most pressing ecological challenges, including species extinction, habitat loss, and invasive species. One of the most intriguing applications of biotechnology is the concept of de-extinction, or the resurrection of extinct species. Scientists are exploring the possibility of using genetic engineering to bring back species that have been wiped out by human activities, such as the woolly mammoth or the passenger pigeon. While de-extinction remains largely theoretical, it raises interesting questions about our ability to reverse the damage we have done to the natural world. However, the most immediate applications of genetic engineering in conservation are focused on protecting species that are currently endangered. For example, gene editing could be used to make endangered species more resilient to climate change, disease, or habitat loss. Researchers are already experimenting with modifying corals to make them more resistant to rising ocean temperatures and acidification, two major threats to coral reefs. Similarly, genetic engineering could be used to create disease-resistant versions of species that are vulnerable to pathogens, such as the American chestnut tree, which has been nearly wiped out by a fungal blight. Biotechnology also offers potential solutions for controlling invasive species, which often wreak havoc on ecosystems by outcompeting native species or spreading diseases. Genetic techniques, such as gene drives, can be used to alter the reproduction of invasive species, effectively reducing their populations over time. For example, researchers are exploring the use of gene drives to control mosquito populations that spread diseases like malaria, as well as invasive rodents that threaten island ecosystems. While the potential of biotechnology to protect and restore ecosystems is exciting, it is not without risks. Genetic engineering, especially when applied to wild species, could have unintended consequences for ecosystems and biodiversity. The release of genetically modified organisms, GMOs, into the wild could disrupt ecological balances in ways that are difficult to predict. There are also ethical concerns about the manipulation of species for human benefit and whether certain species should be prioritized for protection or restoration over others. As biotechnology continues to advance, it will be important to carefully weigh the benefits and risks of genetic engineering in conservation. Transparent regulatory frameworks, rigorous scientific testing, and public engagement will be essential for ensuring that these powerful tools are used responsibly and ethically. The global transition to renewable energy is essential for mitigating climate change and preserving Earth's safe zones. While solar, wind, and hydropower are already well established, ongoing innovations in the renewable energy sector are expanding the possibilities for clean, sustainable energy generation. One of the most exciting areas of innovation is in energy storage. While renewable energy sources like solar and wind are intermittent, meaning they don't produce electricity consistently, new advances in battery technology are making it possible to store excess energy for use during periods of low generation. Lithium-ion batteries have become the industry standard, but research into alternative storage technologies, such as solid-state batteries and flow batteries, promises to increase energy storage capacity, reduce costs, and improve safety. In addition to batteries, other energy storage solutions are being explored. One innovative concept is using excess renewable energy to pump water uphill, where it can be stored in reservoirs and released through hydroelectric turbines when needed. Similarly, thermal energy storage systems store heat from the sun, which can later be converted into electricity. These technologies are helping to solve one of the biggest challenges of renewable energy: how to ensure a steady supply of power even when the sun isn't shining or the wind isn't blowing. Another area of innovation is in offshore wind energy. Offshore wind farms, particularly those located in deep waters, have the potential to generate vast amounts of electricity without taking up valuable land or interfering with human populations. Floating wind turbines, which are tethered to the ocean floor rather than anchored, are being developed to harness wind energy in deeper waters where winds are stronger and more consistent. Hydrogen fuel is also gaining attention as a potential game changer in the renewable energy sector. Hydrogen can be produced by splitting water into hydrogen and oxygen using electricity generated from renewable sources, a process known as electrolysis. When burned, hydrogen produces only water vapor as a byproduct, making it a clean, zero-emissions fuel. Hydrogen is being explored as a solution for industries that are difficult to electrify, such as shipping, aviation, and heavy manufacturing. As these innovations continue to mature, the renewable energy sector is becoming more capable of meeting the world's growing energy demands while reducing reliance on fossil fuels. However, the successful deployment of these technologies will require significant investment in infrastructure, policy support, and public acceptance. In addition to protecting and restoring natural ecosystems, some scientists and engineers are exploring ways to design new ecosystems that are more resilient to environmental stressors. This emerging field of environmental engineering aims to create ecosystems that can adapt to climate change, support biodiversity, and provide ecosystem services, such as clean water and air. One area of focus is urban ecosystems, where engineers are designing green infrastructure to improve resilience in cities. Green roofs, for example, are being installed on buildings to absorb rainwater, reduce urban heat, and provide habitat for pollinators. Similarly, permeable pavement allows rainwater to filter through the ground, reducing the risk of flooding and improving groundwater recharge. These technologies not only improve urban resilience, but also create more pleasant and livable environments for city dwellers. In coastal areas, environmental engineers are developing living shorelines, which use natural materials like plants, sand, and oyster reefs to protect against erosion and storm surges. Unlike traditional concrete seawalls, living shorelines can adapt to changing sea levels and provide habitat for marine life. They are being deployed in areas like the Gulf Coast of the United States, where rising sea levels and increased storm activity pose a significant threat to coastal communities. Engineers are also exploring ways to create artificial ecosystems that mimic the functions of natural ones. For example, constructed wetlands are being used to treat wastewater by filtering pollutants and absorbing nutrients, providing a natural, low-cost alternative to conventional wastewater treatment plants. These artificial ecosystems not only improve water quality, but also provide habitat for wildlife and help sequester carbon. While environmental engineering offers exciting possibilities for creating resilient ecosystems, it is important to recognize that these interventions should complement, rather than replace, efforts to protect and restore natural ecosystems. The goal should always be to work with nature rather than against it, and to prioritize the preservation of the Earth's existing safe zones. Let's imagine a future where humanity has unlocked the key to producing infinite clean energy. Through a combination of advanced solar panels, hydrogen fuel cells, and fusion energy, a technology that mimics the process powering the sun, energy is abundant, cheap, and carbon-free. Every home, city, and vehicle is powered by clean energy, and the world's reliance on fossil fuels is a thing of the past. In this world, environmental degradation from energy extraction is no longer a concern. Forests, rivers, and oceans are left undisturbed by mining, drilling, and burning. Air and water pollution plummet, and the global climate begins to stabilize. The world is transformed as clean energy powers a new era of prosperity and environmental stewardship. But would this world come with its own challenges? Would abundant energy lead to overconsumption of other resources, such as water, minerals, and land? Would societies still prioritize conservation, or would they assume that technology can solve all of the planet's problems? This thought experiment encourages us to consider the potential benefits and limitations of technological solutions to environmental challenges. While clean energy is a critical part of the solution, it must be accompanied by responsible resource management, conservation efforts, and sustainable living practices. As we conclude this chapter, it is clear that scientific innovation and technology will play an essential role in shaping the future of environmental conservation. From AI and biotechnology to renewable energy and environmental engineering, the tools at our disposal are more powerful than ever before. However, technology alone cannot solve the environmental challenges we face. It must be paired with strong policies, individual action, and a commitment to preserving Earth's natural systems. In the next chapter, we will explore the importance of education, advocacy, and awareness in building a global movement to protect Earth's safe zones. While technology provides the tools, it is people who will drive the change needed to create a sustainable future.